Alright, geometry, we are on to the last video of Unit 4, and really this is just an extension of what we've been doing for the last week or so. We are going to be taking the triangle proofs that we've been doing, and we're just going to add one more step at the very end, because instead of proving that just the triangles are congruent, we are now going to be able to prove that their corresponding parts are congruent. So to jump in here, we've got CP-CTC. So we mentioned this before. I mentioned this before back when we were naming congruent triangles. I mentioned that we had to name them in the right order, and this is why. So this stands for corresponding parts of congruent triangles are congruent. So right here, corresponding parts of congruent triangles are congruent. So when you're asked to prove that parts are congruent, so we're not being asked to prove that triangles are congruent, we're being asked to prove like an angle is congruent to another angle or a side is congruent to another side. But the reason I said this is just an extension is that first we need to prove that the triangles are congruent. So we can only use CP-CTC if the triangles are already congruent. So we're literally doing the same thing that we were before and just adding one more line at the end. And you'll see what I mean here. So if we go down to number 1 here, and this video is going to be mostly just proof examples. We go down to number 1. We are not being asked to show that these triangles are congruent. We're being asked to show that angle BCA is congruent to angle DCA. So we're being asked to show, let's see, let me put it in the same blue. We're being asked to show that these two angles right here are congruent. And we're given that AB is congruent to AD. We're also given that BC is congruent to DC. And that's it. So we're not given anything about the angles. We're not given any parallel lines, not that there are any in this, anything like that. All we're given is these two sides. But then we can notice that we do have this reflexive side here, and we have a side-side-side proof. These two triangles are congruent by side-side-side. And we can say actually that ABC, triangle ABC, is congruent to triangle ADC. And what that means is that these two angles have to be congruent because all of the corresponding parts of the triangles are congruent. So if we can prove that these two triangles are congruent, then these two angles also have to be congruent. So it's just adding one more step, and we've already got the side-side-side right here. So we can say that segment AB is congruent to AD. And we can also say that segment BC is congruent to segment DC. So BC and DC, and these were both given to us. And then we saw along the way that this segment AC is congruent to itself. So AC is congruent to AC. And that was by the reflexive property because it's the same thing as itself. And that's enough to show that these triangles are congruent. But this is where we have to be careful naming them. Essentially we need angle C to be congruent to itself. So when we name these two triangles, they better be in the right order. And we can actually use this proof, or what we're trying to prove, to name them because it's going in the same order, BCA and DCA. We're following that double hash mark and then across the reflexive line. So we're going to name the angles that way, but let's go ahead and just use that to name the triangles also. And this is going to work most of the time when you're asked to prove the angles are congruent. We're going to be able to steal the names of those angles and use them to name the triangles in a correct way. So BCA is congruent to DCA, and this was by side, side, side. And now we can show that angle BCA is congruent to angle DCA. So angle BCA is congruent to angle DCA, and our reason on that is CPCTC. Corresponding parts of congruent triangles are congruent. So once we showed that these two triangles are congruent right here, we know everything about those triangles everything about one triangle has a matching part on the other triangle. So since that's true, then our blue proof here has to be true because these angles match up. So triangle BCA is congruent to triangle DCA. That means that angle BCA is also congruent to angle DCA. And we can say that about any of the other angles on here too. Angle B is congruent to angle D. Angle BAC is congruent to angle DAC. So this is true for all the angles, and we already showed all the sides. That's how we showed that the triangle is congruent. Okay, let's move on to another one. Again, we are being asked to prove parts. So that means that our last line is going to be this CPCTC. But before we can use it, we need to prove that the triangles are congruent. And what we have here, we've got some parallel lines. So PS is parallel to QR. And anytime I see parallel lines, I start looking for alternate interior angles. And we've got a couple right here. Okay, we're also given that angle QPS is congruent to angle SRQ. So right here, QPS is congruent to SRQ. And we've got this reflexive side here. So I've got two angles and a side. I can walk across from this angle right here to get to the side. So that means this is going to be an angle side proof. And what we're actually trying to prove at the very end is that these two sides are congruent. So the ones that I've marked in blue. That's what we would like to show. And we'll be able to show that as soon as we show that the triangles are congruent, which we do have enough information to do right now. So we can say that PS is parallel to QR, because that was given to us. And we can also say that angle QPS is congruent to angle SRQ. And that was also given to us. And I'm actually going to move this down to line 3 just to keep my proof in a slightly more logical order, because I'm going to use that first given statement to show those alternate interior angles. All right, so with these parallel lines, we found these two alternate interior angles. They are named PSQ and what's that other one? R. So they're named PSQ and RQS. And this was by alternate interior. And then we also had this reflexive segment here in the middle. So QS is congruent to itself. So QS is congruent to, it's actually going to be congruent to SQ because there is a reflection going on here. And this is the reflexive property. And now we've got enough information to show that these triangles are congruent. I've got two angles and a side. And two angles and a side is always enough. So right here, I can say that triangle, and I'm actually going to steal the names of my triangles from these angles right here. So triangle QPS is congruent to triangle SRQ by angle side. And now if we look here, I've got PQ and RS. So second letter, second letter, first letter. So we do have corresponding sides. So we've got segment PQ is congruent to segment RS. And once again, on any of these, if it's asking you to prove a part, our last reason is going to be CPCTC. Corresponding parts of congruent triangles are congruent. Okay, moving along to another example, and like I said, these are all the same thing. We're doing exactly what we were doing before, only now we're just adding one line at the end. So we're gonna check out our triangle here. I guess first I'll mark what we're trying to prove. We're trying to prove that XWV right here is congruent to XYZ. So over here. Okay, so that's what we're trying to prove. If we can show that these two triangles are congruent in that congruence order, then we've got it. And it looks like we've got two midpoints here, so it's not going to be too hard to do. So X is the midpoint of WY. That means that these two segments are congruent. And X is the midpoint of VZ, which means that these two segments are congruent. I've got two segments. I would sure love to have an angle in between them. And my golly, my gosh, looks like we got some vertical angles here. So we've got a side angle side, side angle side. And once we show those side angle sides, then these two angles here, angle W and angle Y, have to be congruent to each other. So our given here, X is the midpoint of segments WY and VZ, because that was given to us. And then we've got segment WX is congruent to YX. And we've also got that segment VX and ZX are congruent. And in both cases here, this is by the definition of midpoint. So the definition of midpoint says that a midpoint cuts a segment exactly in two. So the sides on, or the segments on either side of the midpoint have to be congruent. Then we've got our vertical angles here, so I guess we better put that in. So we've got angle WXV is congruent to angle, let's see, that's a Y over there, so YXZ. And this was by vertical angles. And now I've got side, angle, side. So side, angle, side. I've got my three parts in here. These triangles are congruent. So triangle WXV is congruent to triangle YXZ. And notice, if you name your angles carefully while you're doing this, then you can just steal the name of the angle for the name of the triangles, and you have a proper congruence. So we've got side, angle, side here. And then finally, we were being asked to prove that XWV is congruent to XYZ. And what's our reason? It's CPCTC. Okay, it's always CPCTC. If you see this, we are being asked to prove angles are congruent. To prove angles are congruent, we use the corresponding parts. But to do that, we have to prove the triangles are congruent first. That's our logical order. Logical order, show three parts. Three parts gets you triangles. Triangles gets you parts, more parts, the parts that we didn't know before. All right, let's do one more of these and then we'll call it a video. So JM is going to bisect KJL. I guess first I should see what we're trying to prove. We're trying to prove that JK and JL. Whoops, that's not the right thing. I want the drawing tool. So we're trying to prove here in this light blue that JK and JL are congruent. And to do that, if we can show these two triangles are congruent, then we'll be in business. So what we're given is that JM bisects KJL. So that's this skinny angle over here, this acute one on the left. And then we've got angle JMK is congruent to angle JML. So that's these two obtuse angles. So we've got our two angles already. And anytime we've got two angles, we just need to find a side. And looky here. They're sharing side JM, which means we've got angle side angle. And once we've got an angle side angle proof, then we can show that these two parts are congruent. So first things first, segment JM bisects angle KJL, because that was given to us. And from that, we found these angles over here on the right. So we've got angle KMJ. No, wait, that's not the ones we found. No, I lied. Angle KJM and angle LJM. So we got the ones on the left. We were given the ones on the right. So angle KJM is congruent to angle LJM. And this is by definition of angle bisector, because that cuts a big angle into two congruent angles. And then from here, we were given one more set of congruent angles. We were given that JMK is congruent to JML. And that was given to us, so that was nice of them. And then finally, we found this side on our own. So JM is congruent to JM. And once again, that's our friend, the reflexive property. You should be getting very familiar with the reflexive property by now. Look for it all the time. It's very useful. We do have congruent triangles now. We've got three parts. We've got angle, side, angle. So we've got our three parts that we need, and we can say that triangle JMK is congruent to triangle JML. And this was by angle, side, angle. And if those two triangles are congruent, then you better believe all of their sides have a matching congruent pair. So JK is congruent to JL. And this is by CPCTC. Corresponding parts of congruent triangles are congruent. All right, I think that's enough time for this video. I don't want to overload you here. You will get some practice on this, but like I said, this is the exact same thing we were doing. If you could do what we were doing before, you'll do fine on this. If you are having trouble with that still, you need to talk to me. And I will see you in class.